Okay, good evening everyone. Let's see if you can hear me. You should be able to hear me. I don't know, I think I'm late a couple of minutes. Apologies for that. Yeah, I was making the most important thing ever, the tea. You cannot hack without having the tea. At least that's, well, my way of thinking about it. Now, okay, let's see. It seems there is like a 30-second lag. Yeah, there's a 30-second lag between me saying something and you folks actually hearing it, so I guess I have to take that into account. Yeah, I'm looking at the lag because the YouTube actually has a new UI for streaming, which kind of confused me. You might have seen that there was a separate stream for a second. That's because the new UI came with a new streaming key, which I was not aware of, but I quickly fixed it. Then I had to press actually the go live button, which was not there earlier, like when you just started streaming, it would stream on YouTube immediately. Now it seems to be not the case with the new keys, so this is kind of, well, something to remember, something to know. Perfect. Now let me just open this, and I guess we can get going. So today's live stream is going to be about the Dragon CTF, or rather the teaser for the Dragon CTF 2019. It was a CTF made by my team, and I've created 3 challenges for that CTF. So these will be the challenges I will be talking about today. I will show you how to solve them, how to approach them, and yeah. And we'll get to that, I guess, in a couple of minutes. The light snake looks blurry. I think that's because it's out of focus a little bit. Anyway, today's moderator, it's Foxtrot Charlie. Foxtrot Charlie, his nickname is right here. I am not sure he's yet. Oh, he'll be here in a couple of minutes, so that's fine. So for now, hold off any questions. I might be looking at the chat, but yeah, just in case, feel free to pass the questions to Foxtrot Charlie as soon as he arrives, and then I will be able to answer them. Perfect. So let's go with some default news, and then I'll jump to the topic. Default news requires a default browser. Here we go. This is Foxtrot Charlie's website, Foxtrot Labs CC. Visit it, take a look, and see if there's anything you can find interesting there. This is a wargaming site I found. Well, actually, I was messaged a couple of weeks ago, and yeah, and I actually liked it. I didn't solve all the challenges yet. There's still one remaining, but in all honesty, I don't have an idea for it, so I'm going to take a look later. Anyway, the challenges on the site are mostly entry level. There are some harder ones, but they are mostly entry level. So if you are just beginning with CTF-like challenges, take a look. You are going to enjoy it. And the creator of this website is still adding more and more challenges. So yeah, it's pretty fun. Cool. I guess I'm going to give you the address. Here's an address for you folks, and how do I do? Oh, I guess I'm going to put the address here. Perfect. Now, once we have that out of the way, Paged Out. You know that the first issue is out. You can take a look, download it for free. It's our magazine where each article is exactly 1 page. So 1 article, 1 page. And there are 57 articles, so do take a look. The address is pagedout.institute. I guess I'm going to give you a link. I guess you might have already seen it since, well, I'm spamming this link around wherever I can. And we are already collecting articles for the 2nd issue. The 2nd issue will come out in mid-November, so in 1.5 months. The deadline is in 20 days, so that's like roughly 3 weeks. We already got a lot of articles. I expect that we will well pass 50 actually, and we have already started the reviews. But if you have sent us an article and not yet received an email from the reviewer, because we always try to confirm, but if you didn't receive the email from a reviewer, do let me know. But on the other hand, be patient, because we started the review process, but we have a lot to go through, so we got kind of delayed in all honesty. But if you're in a hurry for some reason, like for example, you will not have time in late October because of reasons, then let me know and we'll try to push your article up the queue. Now, if you would like to write an article, take a look at these two subpages, call for pages and writing articles. All the details are there. We are also looking for advertisers, and we have two types of ads, but we are looking, well, for both types. We have free community ads, which if you are a maintainer of a project, run a CTF or whatever, you might be interested in this. These are free ads and you do not pay anything, but first come, first served. Everything is described on this page. And if you would like to sponsor Paged Out and actually buy a sponsorship ad for your company, then do let us know as well. Cool, so that's that. Then the CTF itself, yeah. So the CTF, well, kind of looks like this. I guess we are going to look at it in a second. It took place, well, okay, this is in Polish. It took place 1 week ago, 2 weeks ago. 2 weeks ago on the weekend. It was only 48 hours. It was in the teaser format, which means there were not a lot of tasks, not a lot of challenges. I think around 10-ish, but some rather hard ones. Actually, it was a hard CTF. And it wasn't a qualification round for the main Dragon CTF, which is going to happen on the Pwning conference in Warsaw in 1.5 months. It was just a teaser round, just to like show you what to expect on the main CTF, how does the website look like, but also there were some prizes for teams, which are like, the prizes are basically were designed to help teams who want to come to the main CTF, for example, by getting them a hotel for 4 people or for like a travel allowance in case they were like top 1 to top 3. So we got actually a really good feedback for the CTF. As you can see, the score is basically maxed out by everyone. I'm really happy because of that. It's really hard to make a CTF where like everyone is just, yeah, it was incredible and like here have a max score. Which means that the next year's teaser CTF is going to have the weight of 54, so we are slowly growing, which is great. Now the main CTF will also have prizes, pretty decent ones. Actually, we, I think, doubled the prizes or even a little more than last year. So yeah, if you're on the Security Pwning conference, then you can play. If you're invited, then you can play as well. So it's basically open, but you do have to hold a conference ticket one way or the other. Now, PPP has won the CTF. Congratulations, played Parliament of Pwning, like one of the most amazing, if not the amazing teams out there. Well done. I hope they can come to the finals or to the main CTF. P4 was second. I guess I don't have to introduce neither like of these 3 teams. Balston was third, congratulations. And then we had Meltdown, XHP, which is like Hacksorp Shore, Shellfish, Bone Devils. In honesty, I don't know who's that. I'm sorry. I'm sure you're an amazing team. I'm sorry, I do not know about you. I'm ashamed of myself. Neither do I know who's that. Yeah, Bushwhackers, Just Cut the Fish, and then we have Tasteless, Maiden Mim, and so on and so on. Congrats. We had actually quite a lot of teams participated. I guess like 300. Yeah, initially our leaderboard only showed 50, but that was a mistake on our part. You can also, I guess, like take a look on this website and see the scoreboard. But yeah, so I'm going to give you a link to the website, but please note you do need an account to be able to log in. Cool. And yeah, we are going to be looking at a couple of challenges today. We are going to be looking at, start with BabyPDF. This is a task. I'm going to show you like 2 different solutions to it. One is like how you should do it on a CTF, and the second one is a little bit more technical. It might like help you in some other tasks. Then I'm going to look at, where is it? PlayCAP. Here we go. PlayCAP is a medium difficulty, maybe easy, but rather medium difficulty PCAP analysis. Yeah, we'll get there, I guess. And in the end, I will look at Ummm FPU. Ummm FPU, it's I wouldn't call it a hardware challenge. It's a reverse engineering challenge, but there's an interesting twist there. I'll show you later. Cool. So I guess we can get going, but I'm going to take a quick look if there are any questions. So there's one question. from Adam. I'm not showing you questions yet because they are not in our panel yet. But Foxtrot will be here shortly. So Adam asks, would you like to explain why if I run a program owned by root and with suite set, which opens a shell, the shell is not open as root, but as a user who executes this program? So some shells at the beginning basically drop privileges to like check if what's the effective UID, what's the actual UID, and like drop the privileges. If I remember correctly, it was like if you used bash would do that, but if you would like go for dash or sh, it would not drop the privileges and you can use it. That's not really a big problem, but yeah, it happens. Like, yeah. And you do not always have to, like, if that happens to you, just call, I don't know, like a Python interpreter or whatever. These do not drop privileges and you can do anything in them anyway. Okay. And BlameDrop says that love that CTF for sanity check. Sanity check, it wasn't sanity check. Here's the sanity check. Like you just had to enter our oops, you are not seeing what I am seeing. Here we go. Yeah, you just had to enter IRC channel and the sanity check was in the flag was in the topic. It's a way to, you know, to get folks on the channel so if they need support, they can actually chat with the admins. I don't know which team invented that way of doing a sanity check, but it's really it makes a lot of sense. Cool. The map is very similar to Baldur's Gate map. I like it. It's the same map as we used last year. It was drawn by Dalk, by Bertrand, who also made the rest of the graphics and the graphics for Arcane Sector. And yeah, it has a similar style. I might have actually given Baldur's Gate as an example up with some other maps, like what I want to have on the map. Like Arcane Sector, for example, took place on this island. Yeah, just a random tidbit. Yeah, if you're coming to the main CTF, and this is going to be announced, I think officially, like, I don't know, today, tomorrow, when I have time, on the Dragon Sector blog, there will be Arcane Sector on the finals or on the main CTF as well. So if you have not played with Arcane Sector before, you might want to go to my GitHub. There is an Arcane Sector repository there, but all the details will be on the Dragon Sector blog. Cool. And another question. Do you think a dumb person can become good at CTFs? I mean, I wouldn't call oneself dumb, but apart from that, yeah, I mean, from my perspective, it's mostly a function of time and like how much energy you put into it. If you put a lot of energy into it, you will have some, you will have like progress, right? It's inevitable basically, but you do have to put that manual work, manual energy, and yeah, it's time consuming, but it's doable. Okay, why did my desktop disappear? But it appeared again. Oh, whatever. What do you think are the most important technical skills in InfoSec? That depends on the part of InfoSec you are interested in. I would say like whatever skills, but practical, as in you can read about something, you can know the theory behind it, but in the end, practice is what matters. Are the streams back for good? Yeah, basically. Yeah, like the whole September was without the streams, but I think we are back for good. There will be a couple of times until the end of the year where there will be some weeks where there will be no streams due to me traveling or some other reason. Like, for example, I will be on the Google Capture the Flag finals in the beginning of November. I think that doesn't actually, it might influence one stream. I need to check the dates. I'm pretty sure that the Security Pwning conference is also happening on one of the days, or both days are like will make me cancel the stream. But apart from that, it should be fine. we might make a break at the end of the year, but yeah. So that means that for the foreseeable future, we should have these streams. Perfect. Let's start with owning. If you have questions, hold them until Foxtrot Charlie, like this nick here, look at this nickname. When Foxtrot Charlie appears on the chats, do pass the questions to him, and he will be able to like put them in our secret list of questions, and I will answer them later on, so that your questions are not lost. Because well, when I'm focusing on BabyPDF, I will not be able to look at the chat. So BabyPDF, miscellaneous, 121 points in the end. This is dynamic scoring system. It was solved by 124 teams. Yeah, we might make it a little bit, I guess, steeper next time. This is a task for like 40 points. And the flag is in the portable document file nav set. So let's download it. I guess I can give you a link to the file itself. I'm sorry, the link is going to look terrible. Here we go. And that's a good question. Where can I find good security research papers in general? Twitter, surprisingly, but also go to scholargoogle.com. There is a nice archive there. So I guess you folks know it, but scholargoogle.com. Not all security papers are indexed here, but a lot of them are. So yeah, like fuzzing, and you will get some results for this is like scientific papers. Everything here is scientific papers. It's not a website search. It's a scientific search. So yeah, but apart from that, on Twitter, as in I guess like the security community, the InfoSec community is on Twitter and really active. So if you are following people who usually are active on the scene, they will, if a paper that is interesting comes up, they will retweet it. So yeah, that's that. Perfect. We've downloaded BabyPDF. We can now take a look at it. No, we cannot, because I did not create a... yeah, I have not created a directory for the stream. This is bad. Okay, done. Okay, now I do have a new Windows, which means that my Windows console is not as beautiful as it was. It has this black background, but whatever. Are we going to use? No, we are going to use the Linux console anyway, which also has black background, so whatever. Here we go. So we have this file BabyPDF, which is a PDF document, and if we open it in whatever, where's my whatever? My whatever is here. It looks like this. It looks like there is nothing there. The first trick you might want to try is just like, it's not here, but if you press Ctrl A, you should select everything which is in the PDF, but we have nothing to select. So yeah. So what do we do now? That means like the flag is there, but we cannot see it. Now the fast way to solve it is what you do is you launch Inkscape or whatever other graphic application which is able to import PDFs. Okay, Foxtrot Charlie is there, so if you have any questions, you can point them at Foxtrot Charlie. And okay, so this is Inkscape. This is a new document, and I'm going to drag and drop. I'm dragging and dropping the BabyPDF here, and it shows me like, how do I want to import it? Doesn't matter, whatever. And I have this. Now, I guess we can do document properties and checkered background so we see it better. Okay, now if we click here, it's actually like we have to ungroup it. So we ungroup it, and then we can ungroup it again because there are like two groups for some reason. And yeah, you can already see that there is something here. Let me zoom it. And it looks, yeah, it looks like just letters. So I'm going to change the color now to black. And that's it. We have the first flag. Dragons, too bad that World Wide Web is not in PDF. That's actually a really good thing that is not in PDF, but yeah, there we have it. So that's the fast way to do it, and how I expected most people will solve it. Now the slow way to do it is to have a look at the PDF inside. So if we look at it here, PDF is basically a text format, but it's a text format which can contain binary data. So usually when you look at the PDF, there is like a lot of like blah, 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 whatever this is, right? Now, that being said, if you actually like tell this to display it as a text file, it seems pretty reasonable. Now, most of these binary looking data is because that it's actually the stream, this data is compressed by flight decode that tells you it's zlib or like deflate. So what you can do is you can actually decompress all the streams in a PDF, and then it's much more pleasant to look at, and it starts looking like actually human readable. Now you don't have to do it by hand, there are tools for it, and if we look for the tools, here we go, let's look for PDF, the decompress Linux command line, and how to know PDF uncompress. Oh yeah, for example, like whatever, QPDF stream data uncompress, and then we have two PDFs, so let's do that. Then we do the BabyPDF and uncompressed PDF. And now if we look at it, we can actually launch it in a text editor, and it's much more readable. Let me make the font bigger for you. Yeah. So there is a lot of weird stuff, but PDF is basically made of a trailer, which is at the end. It shows where there are objects, and then there are a lot of objects which link of different types which link together, and there's the header, right? The objects always begin with like some object identifier, and then there's like the data of the object ended with end of object, and that's true for all the objects, and there are different types of objects. So this object here is object number 5, and the object number 5 is referenced here. So this is basically like the content of a page, because the page, like this object, is referenced here, like for O, and it's pages. Yeah. So what you see here, it looks funny, but you can think about it like it's a weird notation for SVG. It's not actually SVG, it's a different vector graphic format, but it's a vector graphic format basically. So what you see here are basically like paths and points and coordinates of them, and these M's here or CM's or whatever mean like draw a line from this point to that point, and this gets you actually the shape of a letter and so on. Now the letters in PDFs can either be in vector format or they can be as text plus font, which has a couple of different ways to do it, but that doesn't matter. Now, if I do not understand this, you do not understand this, so what we do is we go to PDF specification, like 1.7, because why not, and it loads, and then here you can look for some of the stuff which we have here. For example, RG. What is RG? I'm going to look for space, RG space, and yeah, and it says that like it's like stroking color or whatever, so that's the color. And let's just like, I'm going to change both of these to 0 and see what happens. Like change the color from 1 to 0, 1 being white, 0 being black. And now I'm going to open the same file in a browser, so I'm drag and dropping unc.pdf here, and we get this. So yeah, I basically just modified the vector image, the colors in the vector image, and we get the flag. So that's a second way to solve it. You do not have to do it for this task. It's way easier with a graphics editor. But this approach with decompressing the PDF, basically, if the task would be more complicated, it might be better to do it this way. And there are actually some good applications to let you explore a PDF. For example, PDF stream dumper, decoder, I think decoder dumper. Yeah, I think it's it. Yeah, it's this application. I use it on most CTFs, in all honesty, PDF stream dumper, and it shows you, it's basically like just a list of objects, and all the objects are automatically decompressed. So it's pretty good. So that was BabyPDF. We can enter the flag, but let's just skip it. And yeah, I'm going to take a look if there are any questions. No questions. If you have any questions, ping Foxtrot Charlie. Like, you have to write at Foxtrot Charlie. Okay. So now PlayCAP, which is going to be a little longer. It's another miscellaneous one. 203 points, 53 solves, difficulty easy. I would say it's moderate, but yeah, easy, moderate, whatever. Here is a recording of the flag being entered into the app HTML5 application. So we have to look at this application to figure out what's going on probably. And we have two files, a new generation PlayCAP file and an app HTML. So yeah, we are going to download both. I'm going to, this is how the app looks like, I guess. I'm going to give you links to both files. Here we go on YouTube. This PDF dumper sounds like a quite vulnerable piece of software. Not really, because it doesn't really... I mean, unless you have an exploit, right? But the basic features are quite easy. It doesn't try to do any processing of what's inside, apart from like unpacking the most outer layer of the structure. Most bugs in PDFs are in the inner layers. Okay, so I gave you the links. I have not downloaded this. Let me open it. So yeah, this is basically like an... Yeah, what is it? Looks like a keyboard. Yeah, this is me pressing an arrow, but this doesn't matter. Yeah, I'm typing, nothing happens. I don't know. Yeah, we have to analyze, we have to check in the source code. Hopefully it's not obfuscated. What is this? So I'm going to go here to look at the source code. We can make it a little bit bigger. And let's just look what's here. There's some CSS, we can usually ignore it. There's some HTML, we can ignore it. And there is a lot of JavaScript, and it says, yeah, like screen keyboard, and gamepad position, and gamepad buttons, and handle buttons. Okay, so just like skimming through it and looking at keywords, looking at names. I'm not analyzing this code, I'm just looking at the names. And like window, gamepad buttons though, whatever. Pad buttons, yeah, okay. So basically this already should tell me that probably this little application is, you have to have a gamepad connected to be able to move it, which kinda already tells you what's in the PCAP file, right? If you need a gamepad and the task says that there has been like recorded how the flag was entered, that means somebody was using a gamepad to enter this flag. So there we have it. We already know what's in the PCAP even without opening it. We might be wrong, but we probably aren't. I'm going to leave this open. We are probably going to look more on this, or rather, instead of leaving it open, I'm going to, let's do it like this. Yeah, I'm going to copy paste it to an editor. Okay, cool. Now, let's take a look at the PCAP. I'm using Wireshark as usual. Yeah, I think I need to finally install the update. Perfect. Now, what do we have here? Oh, we kind of know. There is USB traffic. So there is like typical USB setup, and then I'm just scrolling down to see what's going on here. There is only this one packet being exchanged, URB interrupt. And there is quite a lot of packets. I'm scrolling, and there's quite a lot of packets. So can I actually zoom it? I can actually zoom it. I am amazed by Wireshark. I had no idea what's possible. Perfect. So let's take a look at the, this is basically the host chatting with a USB device and trying to establish what kind of a device are you. And the USB devices are identified by two numbers, same as like PCI devices basically, which is the vendor ID and the product ID. And which means that the device is probably saying at some point that, yeah, I am this kind of a device. So the vendor ID is this, and it says that it's Nintendo Corporation. And the ID of a product, Wireshark doesn't know it, but that doesn't mean anything. We can just do like 157E:2009 and Google for it. Wait, it actually treated it as a as a IP6 probably address. Okay, so yeah, like Nintendo Switch Pro controller. But that's it. I mean, we already know what we needed. It's a it was a gamepad indeed. So yeah, the gamepad was initialized, and after it was initialized, somebody was playing with the gamepad to enter the flag to this application. And what we have to do is we basically have to somehow replay this PCAP for this application to see what flag was actually entered. And there's an excellent question from Brehm. For PlayCAP, are there some tools that would simulate repeat the USB traffic from a PCAP file? Could that work? It probably might work, depending if the driver doesn't set some state on the device and expect the state to be there, then it actually might work. I do not know of any application to do that for USB. Someone was playing Zelda recently. No, not really recently, but I did play a lot of Breath of the Wild, like Legend of Zelda. Are we still using the way of configuring Windows plus Linux that you've described on the stream? Yeah, I'm still using it. Cool. So, what we are probably interested in is we are interested in these URB interrupt in packets where the destination is the host. So the device, this is the device, is sending it to the host. We probably do not care what the host responds, especially that the host, like, what can a host tell a gamepad? Like, maybe like change the sensitivity, maybe like create a dead zone, or maybe like you need to vibrate the pad now. But we do not care. What we really care is the in packets where the device is telling the host, like, I moved like the joystick, or I pushed a button. And this is what we are interested in. We are also not really interested in the packet itself. We do not care about like the destination, the ID. If we can help it, we do not care about it. What we care about is the leftover capture data. So this is what we will want to, what we need basically from here. Now, can we, I don't know, somehow filter, conversation filter, no. Okay, that doesn't matter. I was looking for one option, but that option doesn't really matter. Now what I'm going to do, and please bear with me for a few seconds. Okay, here we go. Now, there's one trick which I learned from, if you actually like look for CTF, PCAP, HID keyboard, like if this would be a keyboard, then there's actually a really good write-up about it. I think it's either this one or this one. Let me look for what I wanted. No. Yeah, basically, like you can run Wireshark in command line as tshark, and then you can actually extract some fields from a PCAP using this command line tool. And what we will want to do is we are going to want to extract some, basically some like all the leftover data here. So let me do maybe USB transfer type. We want it to be set to 1. This is which field is it? It's one of these probably. Set it to 1. Yeah, it's so we filtered the packets by only getting this like URB interrupt, but apart from that, we also want to filter it by I don't know if we actually want to filter it by anything else. From all I care, that's actually enough for filtering for me. So yeah, this is the only filter, and now the fields which we need is this. It's actually called cap data for some reason. And what we need to do now is we need to basically dump the data to a file. And to do that, I need to remember where my Wireshark is. No, it's probably in C program files. Wireshark? Windows Defender? No. Wireshark? Yeah, Wireshark. And where is tshark? here we go. Okay. Yeah, it wants to, I'm telling it no, because I do not want it to, yeah. I do not want it to start sniffing the network right now, because it would just flood the screen with everything. We wanted to display the PlayCAP, the captured traffic. What is it? Wait, did I forget to? Sorry. I do need -r. I always forget about that. Okay, yeah. And now it displays it. But we want it to be displayed in a different way. We want to do the filtering. The filtering you do by $Y. And in our case, the filter is, we probably need this. In our case, this is the filter. Yeah, so we are getting only this. And now we needed to tell it like what kind of fields do we want to show. We want the USB capture data. So USB dot, I'm sorry, you probably do not see it. Yeah, USB dot cap data, which is the capture data. And we need T fields to actually display it. Okay, so this is the capture data. What I would like apart from the capture data is also the time. Now, why do we need the time? Because like if somebody pushes a button, right, we only need to know about that the button was pushed, but we might also require to know about how long was the button pushed, because there is a, what's it called? There is a, like, if physically you push a button, then there is a moment when it's being pushed, when it starts to basically like connect with the other side, right? So that it becomes active. But then both sides start to like slowly vibrate or really fast vibrate, and due to that they lose connectivity and gain and lose and gain until the button is pushed enough that it's a stable connection. And the same when you go up. And due to that, there might be like one button press might be seen in the traffic as like a couple of presses, and then a long press, and then when it's let go, it's like pressed, then a couple of like let goes, and then it's let go for a full time. So that's why we need the time to try to filter out these, these basically like artifacts, physical artifacts, if you will. So let's also add the time. And to add the time, I need another -e, and it's frame.time and approach. Okay. Okay. And now we obviously do not need it on screen. We need it in some text file to be able to look at it in a more insane way. So data.txt maybe. Yeah, debouncing. I think it's debouncing. Thank you, Bart, and thank you, no one. The phenomena I called is called debouncing. Okay, what's this? This is the USB address, because USB is basically, I'm not sure if that's true for USB 3 or USB-C, but that's totally true for all the previous versions. USB is basically a device tree, which means that you have a USB controller, which is connected to a USB switch, to a hub, USB hub actually, and this might be connected to like a couple of devices. And each device, let's say that this is a device, each device might have a couple of endpoints. There's usually like a configuration endpoint, and there's like an interrupt endpoint, might be an interrupt endpoint. I don't know why it's blinking like that, I'm sorry about that. Yeah, like interrupt breakpoint or like just data exchange endpoint. So yeah, the one I believe would be then like the hub number, then there's the device number, and then there's the endpoint number. So one would be the endpoint number. And this device like probably has two endpoint numbers, one for configuration and the other for whatever. And 1 and 8 depends on like the computer it was connected to. If you have a lot of USB cards and USB switches and whatever, then it might be different. Okay, we do not need to look at that anymore. What we can take a look, I need to remove this finally from... Yeah, I was decrypting some TLS traffic, that's why it's... But when I removed the key, that's why it's complaining. Cool, let's look at the data. Here's the data. Now I'm going to show it as without dropping. And yeah. So, do you know how to interpret the data? I don't. But that doesn't matter too much. What we need to know is, let's go here, HTML5 gamepad. There's a website to test the gamepad. And no controllers were detected. That's not good. Okay, I'm going to connect one controller for a second so you can take a look. Okay, this is going to be an Xbox controller. Okay, here we go. Now, what you need to know and to realize is that these are buttons here. Like, don't look at the camera, look at the website. So if I start pressing the buttons, there's actually quite a lot of buttons, like 16 buttons. And we have to know that there is like a lot of buttons and how many buttons there might be. On a Switch controller, I think it's around the same, but there might be like one or two more. And why is that important? That is important because what we need to do is we need to figure out where in this data, which bit in which byte is responsible for which button. So that's what we need to do. And because looking at the website, right, we can be fairly certain that somebody, like maybe in a game you push several buttons at once, but on this website you probably pushed like directions to select the letter and then pushed a button to accept the letter. But you didn't push many buttons at the same time. So what we will be looking at in the data is basically changes in like single bits. We will totally ignore large lumps of data. Like for example, we will ignore this, I guess, here, because there's like a lot of data here, there's a lot of data here. There's not a lot of data in these columns, so we might want to focus on these columns. Why are we ignoring these lumps of data? Because my guess is that these are from like the analog controller, which needs to send a lot of data, because that's like probably a floating point number or whatever. So that is more data. This number is, by the way, growing all the time, so this might be some kind of a timestamp or whatever, so we can ignore it as well. And yeah, so if we are ignoring this, and we are ignoring this, then what is left is in the middle. Another way to approach it, because this is basically like educated guessing. I know how protocols work in general, therefore I can reason that this protocol is going to be as simple as possible, and each button will be represented by probably one bit. I might be wrong, but it's a pretty decent guess. An educated guess, not just like a guess. Another approach to it is actually to go and find the drivers for this, for example, like in the Linux kernel or in like some other GitHub projects, and take a look there and look at like what button is what, but we will not do that, we will focus on this. What we need now, because I'm obviously not going to I'm not going to look at it by like, you know, just by my eyes. I am going, however, to try to figure out which parts are interesting. No, I think I'm going to focus on the column which I showed you, on the columns, because yeah. So what I'm going to do, I'm going to write a Python script called go.py, because why not? I started using Python 3, so watch out, this is Python 3. I'm not saying I'm good at Python 3 yet. Okay, and we're going to load this data, so with open data for processing, we are basically going to do the processing in Python. As read split lines. Okay, and this is like data for ln in, it's called lines. For ln in lines, what we need to do is we need to split what are we splitting by? Is this is a tab. If I press one's arrow right, it jumps a lot. So this is a tab. So we are splitting by a tab, which means we'll be getting like the timestamp and the data. Cool. So I got the payload. Payload is called payload. ln split by a tab. Okay. And now we need the timestamp. It's a float. So let's convert it to a float. And the payload needs to be decoded. So because it's in hexadecimal text format, text encoding, right? So I would prefer to have like bytes from hex. This is what I was missing for a long time in Python 3, but now we have it. So yeah, payload. Okay. And I'm just going to run it to make sure that I didn't make any typos. So Python go. Not enough. Yeah, I'll have it stay hard. Expected to get one. Why? What? Oh, wow. Slash instead of a backslash. You didn't see that. That's embarrassing. Okay, it works now. Perfect. So, what I want basically is I would love for the payload. Oh, let's make, I like bytes, but I like byte array more. Let's use byte array. Now, which bytes are the ones which I said that are probably interesting? Okay. Now, I said this might be some kind of a timestamp counter. Is it little endian or is it big endian? After we get to FF on this column, will this flip to 31 or will this flip to 92, sorry. And FF, no, nothing flipped, it just reset. Okay, so that's probably not a timestamp. Cool, so I'm going to end here. So the 3 bytes, I do not care about the 3 bytes, then I care about 1, 2, 3, about the 3 next bytes. This is again guessing, this is guesswork, I might be wrong, but let's see how it goes. I don't think I care about anything later on either. Okay, so yeah. So data, like let's call it maybe buttons. Maybe buttons are at where are they? 3 and 3 plus 3, right? Yeah. So let's print maybe buttons hex. Do byte array has that method? It does. Okay, perfect. Cool. Now I do not really care about like displaying all of this. What I really care is about the changes probably. So let's do it like this. Last is equal to whatever. Like I don't know, byte array 3. This kind of a whatever. And if maybe buttons are not equal to last, I want you to print them and I want last to be set to maybe buttons. So it only shows me the differences now. Okay, and let's see what we have to work with. How many buttons should we expect and like to be used? And that's a good question, and it's a question actually for the application. Let's look at the application source code. I believe I had the application source code somewhere. Here we go. Okay, let's see how many buttons are actually referenced in the code. I guess here, like, I just randomly stumbled upon this. We have left, right, up, down, and reset and select. So left, right, up, down means that we are probably not using the analog, you know, whatever joystick. We are using probably the digital direction pad, the D-pad or whatever you call it, right? This. Cool. So, okay, so 6. We are looking for 6 different bits. What we could do is, I'm just going to like look at it with my eyes. I'm ignoring the beginning packets for now. I might stop ignoring them later on. So I'm going to go here, and we have what? We have this 8 here it's always here. Like this 8, right? It's always here, so I'm going to ignore it. Then we have the bit on the, like, you know, if we have bits, right? That means that this is 8, 4, 2, 1, like the values behind the bits. So 4 means it's a bit on the 3rd position, counting, like assuming that the rightmost bit is actually that this is the first position. It's actually a 0 position, right? So let's call it like a 0th position. This is the first position. This is the second position. So 4, it means we found 1 bit. This is another bit. It's this bit. Then 8, another bit. So we have already 3 different bits. Then we have 2. That's 4 different bits. And this is an 8 on another one. So this is like 5. And we need 1 more bit. And I'm pretty sure these are the buttons right now. Okay. So wait, what's the other button for? It's for selecting and for resetting. Okay, probably resetting will happen at the end, beginning, I don't know. Is it resetting the flag? Okay, there are quite a lot of different bits here. One of them might be resetting. I don't know. I don't really care too much about it. So what I'm going to do is I'm going to look at the code, because assuming these are the buttons and assuming I will be able to figure out which button is which, I would need to know how can I replay it in the application. So there is this handle buttons function which takes the action and the state. What's the action? The action can be the name of the button. And the state is, it has to be true, because if it's false, then it just returns. So it's probably like, is it pushed or is it released? True if pushed, released, false. Cool. And I guess we are going to just call this function, like, we are going to print out calling this function for whatever button we assign to it, and then set this to true. Oh, thank you for the donation, Zero. How are you? I'm fine, thank you. How are you? Okay, how are we going to be guessing which bits are representing which button? Well, my guess is that if we are going to choose letters here, right, we will have to use a lot of D-pad and not a lot of select or reset, which means that this 8 here is probably a select button. Again, I'm doing guesswork right now, right? And these bits here are for using the direction or for the D-pad. I don't know which directions, but still, that should be enough. Well, not yet. We'll have to figure it out, obviously. Cool. So, what can we do here? We can basically do... Oh, I just realized the packets which are at the beginning, which are looking really weird, right? Wait, this is the wrong data. You know what? I'm going to do CLS and I'm going to print it again. Here we go. These are probably from when still the exchange was being done with whatever with the host. Here, I'm going to start with here, and I'm going to assume that 2 is a reset. So somebody pressed reset a couple of times and then started entering the directions, which means I need to basically remove the first, I don't know how many. I'm going to remove these lines. How many lines do we have here? We have here 25 lines. So I'm going to remove the 25 lines from the lines. So lines is lines, but without the 25 lines at the beginning. Perfect. CLS, and let's do it again. Cool. Oh, we still have these ones I said. So 1, 2, 3, 4, 5, 12 more. CLS. Oh, okay. What am I doing wrong? Why is it not removing all the lines that's supposed to be removing? I'm doing something really wrong. Whatever. Plus 10. CLS. Okay, now it's fine. And we have a free. I don't know why I needed to add that. Whatever. Cool. So now I'm assuming the 2 is the reset. So if wait, when am I printing it? I'm printing it here. So So like this. D is equal to this, and then I'm going to print D and X. And X is going to be nothing unless the byte array of maybe buttons of 0 and 2, or rather this. If it's true, then I'm assuming that it's basically the reset. So I'm going to call this function. By call this function, I mean I'm going to write JavaScript code which is going to call that function. Is it a global function? It's not, but maybe we can make it global in a second. Let's make it global. How do we make a function global? We assign it to the window. Window handle buttons is handle buttons. Perfect, now it's global. Print, no print. Window handle buttons, and we are sending it. I said it's reset, so let's say it's reset. Oh, I thought it's resetting the flag too, but it's not. Okay. And true. And yeah, semicolon. Perfect. Now, these are going to be directions, like these, like 4 ones and so on. But this 8 here is probably going to be the select button. So if maybe buttons of 0 is and 8, I said that's probably the select button. I'm guessing. I might be wrong. Now, let's look at the first initial couple of moves, because we know the flag format for the CTF. The flag always begins with Dragon. So that means that D, capital D, is going to be first. So somebody needs to push the direction right once, twice, 3 times to get here, and then accept it. Let's look here, resetting, then for once, twice, 3 times, and selecting. So somebody just went to D and selected it. So we know that 4 is right. Okay, so we know that. Okay, so 4, but in the second byte. Yeah, this is first byte, second counting from 0. And we said it's right. Okay, then D, then slower r, smaller lowercase r. It's going downwards 1, 2, 3, 4 times, and then selecting. So after this, we have 1, 2, 3, 4, and selecting. So 1, we know 1 is going down. You see, it's just like puzzles, like Sudoku. This is down. And after we selected it, yeah, this is down. Where do we need to go? D, R, G. G is 1 up and 1 left. And yeah, it could be either way. This could be like, this could be up and this could be left, or the other way around, I don't know. So yeah, I don't know yet, but I am going to do like this, 8. And then when we are on the G, N, we need to go to N. N is here. So we expect 1, 2, 3, 4, 5, 6, 7, 7 times R. Right. And it's 1, 2, 3, yeah, something like 7. Yeah, I don't know. I mean, we can just brute force it, right? So, yeah. Let's assume 8 is left, because why not? Because I'm just going to assume that left is next to right and up is next to down. So this is up. And that's it. And so let's print it again. CLS print it. Cool. And now I'm going to do a different thing. I'm going to only, if X is set, print X. Otherwise, don't print anything. And yeah, and we have a reset at the end. This might be wrong. I might have it like in an opposite direction, whatever. I'm going to put it in ASDF, open the ASDF in here, and now I'm going to open this modified version of the web app. Open the console. Oh, I need to do this. And now I'm going to copy paste it into the console and press enter. Here we go. I think we guessed the correct order, which is left and which is up. So that's it. Dear GNS, let's play a gamepad. That's the second flag of the day. Cool. So yeah, this task was like, again, you could solve it in both ways, right? You could either go and find a driver which has like all the definitions of the protocol and take a look where are the buttons, or you could just do this weird guessing, which I did, which isn't really guessing, as you could tell, because you have a lot of clues about like what the movement was supposed to be, just looking at the app and like how many buttons you had it in the code. And yeah, so you could just guess about it. If this protocol would be more complicated, because it doesn't look complicated, but if it would be more complicated, I would probably go and analyze some driver. But it wasn't, so here we go. We got the second flag. Okay, now I believe we have to go for the third flag, but there are a couple of questions, so I'm going to answer the questions. The questions will appear here. Okay, yeah, I already answered that question. If I'm using the Windows Linux configuration, yeah. If there is some tool to simulate the USB traffic from a PCAP, I do not believe so, but maybe. Yeah, what does 181 identify as the address of the endpoint or device and endpoint on the USB bus? The bounce shouldn't be visible on USB pickup gamepads, firmware or hardware. Low-pass filter would take care of this effect. This is a really good remark. Thank you for making it XDA044. Yeah, we did not see any debouncing problems. That's good to know, actually. I didn't know that gamepad does it. Yeah, yes, this Dohan, you are absolutely right about me messing up the slash and the backslash, and yeah, I'm sad you had to see that. I'm sorry. I didn't solve this challenge, I created this challenge, so I know what the challenge is about, therefore I'm cheating. But I did test this challenge without looking at driver code, so when I was testing this challenge, I solved the protocol riddle the same way, exactly the same way. How to set up a virtual USB device to use PlayCAP for replaying this pickup? Yeah, I have no idea. It's a really good question. It's a really fair question. If you do that, let me know. I would be really interested in like seeing the write-up. Because of custom, maybe buttons printing. I do not know what this is referring to. I'm sorry. Perfect. We can go and again, if you have any questions, ping this guy. Like Foxtrot Charlie at Foxtrot Charlie at our IRC or YouTube chat or Discord actually, then he will pass the questions to me. Which means we can get going with the last and the main dish of today's stream, which is FPU. It's 400-point reverse engineering. This is like the dynamic scoring is exactly right here. I would also rate this task as 400 points. It's not simple, but it's not complicated either. It's like there's a lot of work, but there are no heavy tricks. There are some tricks. Oh, heavy tricks. And it says, so I found this micro mega FPU in my drawer, connected it to an Arduino Uno, or Uno, however you want to read it, and programmed it to validate the flag. And you get 3 different files, which is a screenshot. We can take a look at the screenshot. Yeah, kind of. This is a screenshot, which looks like part of the Arduino IDE, the COM monitor, which says FPU version, FPU, FPU and the version. Then it says flashing FPU's EEPROM and it's doing something. Please enter the flag, and there is nothing here. Checking, wrong flag, which means like somebody entered the flag and clicked send. You can see it's still highlighted and the flag was wrong. So this is what because we are probably not going to be able to run this task, we will have to do like a cold analysis, basically, like a dead code analysis. Then at least we got a screenshot to have in our mind what this is looking at. Now, what's this like FPU thing? So let me show you. It's this. Yeah. What this is, it's actually, well, you can see it's an integrated circuit in a, what's it called, like parallel inline package? No. PDIP? Whatever, it's a PDIP package. Yeah, and it looks weird because it has a sticker at the top, and usually integrated circuits don't have a sticker. They have, well, just, you know, in the plastic, the name of whatever this is, but this one has a sticker. So it's either custom made, or if you remove the sticker, there's actually something else there. And the something else is actually a PIC microcontroller, a PIC microcontroller, and this microcontroller has a firmware inside it, which basically gives an FPU, like floating point unit, like API over I2C and over SPI interfaces, so you can connect it to an Arduino which doesn't have floating point operations, and you can use this to do 32-bit floating point operations for your Arduino. And you know, this was made by Micromega, which is like a Canadian company, probably a small one, I'm guessing. And back in the day, I got several of those. Well, actually, several, only two. There are also other versions. These are really hard to get right now. So my guess was that nobody is going to have one of these. And it's actually pretty amazing because you can put the, like, whatever code you want to write, basically FPU bytecode, which you want to execute, on the EEPROM here, and it then tell it like, okay, I want to execute it. And this is where the flag is stored. Like at the beginning, the Arduino is flashing the bytecode to the EEPROM, which is basically FPU code, doing the calculations and so on. And then the Arduino is going to call the routine and give it the flag, and this bytecode is going to check it. I do not believe there were any emulators before the CTF. I know that during the CTF some people created emulators for this, and there were no disassemblers as far as I could tell, but there's a lot of documentation that we'll look at. Now, yeah, again, this was connected when I was programming this task. This was connected to a typical Arduino, and I also used what's it called, Shikra? Yeah, the Shikra, which is, come on, focus. Yeah, the camera doesn't like you. I'm sorry. Am I going to really have to show you the, like, okay, here we go. Yeah, what this is basically like USB here, UART here, and some other protocols. So, because this on a couple of pins has a UART interface, which you can use for debugging whatever application the bytecode is running, and was really useful while developing it, but it was not really needed while solving it. So for solving it, you do not need the hardware at all. What you need is the documentation, and to find the documentation, we need to look for it. It's the Ummm FPU, and Google actually also tells you the version. This is this version. So here we go. And we go to the website of this company, and you have some more information about what this actually is. And what this actually is a floating point coprocessor. It has some instruction buffer. It has 128 registers, which is quite a lot. 32, they are both for integers, and they're both for floating point units. It has some string processing, it has some Fourier operations, it has matrix operations, and it has both floating point and long integers operations, like 32-bit long integer operations. it can work over the I2C interface, which I connected it to the Arduino like that. It has the EEPROM for the bytecode, but apart from that, it also has a flash memory for the bytecode, which is which can only be programmed by this like any UART interface basically. And yeah, and there's this debug monitor, and there are also like two digital outputs, a timer, and like an ADC. These are basically like these are features of the actual PIC it's running on. So it's not, when I was designing this task, I still thought it's real hardware FPU, but it's actually a FPU virtual machine running on a PIC microcontroller. Yeah, that doesn't really matter too much. What matters is that if we scroll down, we get the datasheet and the instruction set. So that's one thing. And then there's also supported software, so we can go there. And what we can download here is for the free one. Yeah, there are the opcode definitions. We can download them. We can download also the files for like Arduino, for example. Cool. Now, oh, it moved me just here. So here we go. And this and matrix operations. Okay, and this is what we need to solve the task. I guess I'm going to give you a link to this, unless you already Googled it. And I'm going to give you the link to the files. And again, we have 3 files. The inno file, this is just like C++, I don't know why Arduino calls it inno, but whatever. H, which is a header for the C++, which means we do not have to do any reverse engineering on the Arduino. We already get the source code. And the screenshot, which I already showed you. Oh, I guess I can also show you how it was connected. Okay, this is how, yeah, it looks connected to like the Arduino. No magic. And let me give you links to these files. I'm going to give you a link to the screenshot too, because why not? Cool. So let's take a look at the source code. We are going to look in the documentation later on. Let's take a look at the source code, but I need to create a directory. Oh, by the way, I open sourced this, like all 3 challenges, so they are on my GitHub as well. Okay, well, I did not download the challenge. I gave you links, but I did not download it myself. Here we go. Okay, so generated.h looks like bytecode. Yeah. Then the inno file. Oh, sorry, give me 1 second. Okay, yeah, I did tell people how it's connected, so there was no guessing. As you can see, like the 7th pin is connected twice to the same pin on the FPU. This is basically to do monitoring if the FPU is ready, because this pin was reused for like both transmitting the data and also to tell whether it's busy or it's not busy, it's ready. Okay, goodbye infinite loop, perfect. FPU wait, we don't care. FPU for sync, we don't care. FPU EEPROM upload, we probably don't care. Especially that it takes like a slot number. I have no idea what's a slot number yet. Well, I know, but me solving the challenge for the first time wouldn't know. And yeah, my bet is that this task here is going to be called with this function. Looks long. This looks like standard EEPROM programming. We do not care. Setup. What's going on here? Pin 7 connected to the ready signal. That's what I said. Serial to communicate with the console. The serial is what is this. This is like all the prints that go to the serial are related to this, to the screenshot. Then SPI begin, FPU begin, and it synchronizes with the FPU, writes whatever this is, writes a version, and then reads a string from it, and it says that the FPU version is something, and it checks whether that version is exactly this FPU, so the players didn't have to do any guessing, they knew what exact version of FPU is. It's also on the screenshot, obviously. And yeah, incorrect FPU or not detected if it doesn't work, and goodbyes. And then in the main function, which is called loop, which isn't really a loop, it flashes, the task slot with the task. This flashes this byte EEPROM of the FPU. One thing we would probably need to check, however, is whether the EEPROM does any decryption, like the EEPROM upload does any decryption. Is there any decryption here? Okay, so it loads the data from the EEPROM to verify it, because it's faster than writing. So it checks if on that byte of EEPROM the data is already there, and maybe we do not need to write it because writing is super slow. And then it checks if EEPROM and written. Written is this. What's EEPROM? EEPROM, no, this is from the EEPROM, and written is from the data. So we just grab, oh, it's actually not 1 byte, it's 4 bytes. So if it's equal, then whatever, that means that this already means that there is no encryption. It's just like this bytecode is decrypted, there is nothing else here. Yeah, FPU write, data uploaded. Yeah, there is no encryption, that's good. Cool, so going back to this here, the code is super small actually, like only 170 lines. It says, please enter the flag and password, sets timeout, the serial timeout to, I don't know, is that like 60 seconds probably? And then it reads the flag from the serial, so somebody typed in the flag and pressed send on the Arduino monitor. Flag is trimmed, and then if its length is 0, then no flag was entered. Trimmed as in like, you know, like stripped in Python terminology. Then we wait for the FPU, we write str set, whatever that is. We then write the flag and write a 0 at the end of it. And then we do a call, well, call, that's probably like, this is probably an opcode. We need to take a look, but that's probably an opcode. And it's probably calls the function which is at the beginning of this bytecode. Because this start slot, like, yeah, start slot, task slot, like zeros in both cases. So it writes the flag somewhere, and then it just calls the bytecode, and the bytecode does processing, it says wait, and then the result, it gets a string from the FPU, and that string is being displayed. So this is like a typical harness code, which, yeah, gets the flag, sends it to the FPU, asks the FPU to verify it, and then checks whether, like, what's the result. Cool, so having this looked at, what we need to look at is we need to look at this code here, at the generated code here. Now, for the sake of time, I'm going to cheat a little here, and I'm going to tell you a couple of things. First of all, but you know what? First of all, let's actually, we can turn this off. Let's go to, where's my browser? Here's my browser. To the datasheet, and let's look up the opcodes, which are here. Equal, this is the datasheet, but I wanted the instruction set. 68 pages, not bad, not good. Okay, equal, call EEPROM user-defined function. And if we look at it, it's call EEPROM memory user-defined function. Fn is the number of a function, so this is not an address, this is and this is just 1 byte, as you can see here. The user-defined function n stored in EEPROM memory is executed. Up to 16 levels of nesting is supported for this function for function calls. The EEPROM, so that means that like you cannot really do a lot of recursive coding here. The EEPROM functions can be stored at runtime using the EEWrite instruction. And if we look at the EEWrite, the EEWrite was it used here? Yeah, it's used here for programming the EEPROM, so this is actually what's going on here. If we look for this function, we can read bytes are stored sequentially in EEPROM starting at EEPROM address slot. The number of bytes specified by BC, this is BC, are copied to EEPROM starting at address slot E. Address slots are 4 bytes in length, so this means that the addressing in the EEPROM is you do not address individual bytes, you address individual 4-byte words. So have that in mind. Consecutive address slots are used to store blah blah blah. The instructions can be used to store multiple values. Okay, now I'm going to skip a little reading through the documentation and tell you a little bit how the EEPROM is actually, how the functions in the EEPROM are actually constructed. It's as it said in the documentation, each EEPROM slot is actually 32 bits, which isn't fully true, but let's assume for the sake of a discussion that it is. And we are loading our function to the slot 0, right? So we begin from the address 0, however you look at it. Now, at the beginning of a function, what you need to put, and the function needs to be at the beginning of a slot. What you need to put is you need to put 1 byte of how large is this function. Meaning that, for example, if the function would be, I don't know, 20 bytes, right? You would put 20 decimal or what's this, like 14 hexadecimal there. So it works 14. At the beginning, right? So you put 14, and then you put the bytecode, and then at the end you have to put the return address, because once you do an EE call, then the firmware checks this length, like the length, and if at the end of that length there is the return address, the return instruction. If it's not there, then the documentation says it fails. I have no idea what actually happens, and this check is done by when calling. Writing to EEPROM is super slow, but actually reading from it is quite fast. So yeah, what we have to expect at the beginning of EEPROM then is the length. So the first byte here in the generated, this is going to be the length, and the length is set to be 7. Then what we can do is we can look for the read instruction. Yeah, read has the opcode 80, which means that after the 7 bytes, we should have an 80. So this is 1, 2, 3, 4, 5, 6, 7, and we have 80 at 7, which means that this actually works. And then we have another function, and this function is already larger. So now what we need to do is we probably need to store this data inside some binary file and start write a disassembler for it. Cool. So I'm going to copy it. I'm going to create a new file called dump.pe. Here we go, and I'm going to do like A is a byte array which takes a list of these bytes, and then I'm going to just write it like with open dump.bin, write binary as write what did I call it? A. Yeah, okay, that's it. And I'm going to run it just to. Is this sorry? Do I have a console open? I do not have a console open yet, so let me open it. Again, I'm using Python 3. That doesn't matter in this case anyway. Dump. Okay. And we have this dumped. The bad news is that we cannot see any strings. We can, I guess, take a look in a hex editor too. Yeah, the entropy of it seems somewhat high-ish. well, here it's an obvious padding, obviously. Here's an obvious padding. So these are like padded to slot sizes. Okay. So you have it dumped. Now we need to check how many functions are there and at what slots. This is like the first thing we need to do. So I'm going to create a dis.py for creating a disassembler. You might want to take a look at the episodes about reverse engineering virtual machines, which I have on my channel. This is going to be, solving it is going to be like solving those, yeah, like solving those other tasks related to VMs, but it's, I guess, a little bit simpler. Okay, with open dump bin as binary. I want to read it as data. And I want to put it in a byte array, again, because I like byte arrays more than I like bytes. This is again Python 3. Cool. Now we need to basically make a list of functions. So let's call it funcs. And I is at the beginning 0, and while I is less than length of data, we check the length of the function. So L is the d of I, then we can increase I by 1. Then we have the data of the function, so let's call it data, and that's I plus L. Let's call it a z, like size. And we can add a z to that, and then there might be some padding, which basically means, but the padding is only there if we didn't hit the boundary of, so if I is, I modulo 4 is not 0, that means we are not at the boundary of a word, we need to skip some bytes, so I plus equal 1. And this byte actually, like, if this byte is not 0, it's not padded with 0. We did see in the hex editor that these are padded with zeros. But if these are not padded with zeros, then if these are not zeros, that means that something is wrong with our understanding, and we probably need to raise an exception to let us know about it. Wrong with padding. Now this, yeah, I should usually add like an offset here to be a little more descriptive, but whatever. And at the end, after we do that, we can, to the funcs, we can add, let's append like the slot number is, I don't know what's the slot number. The slot number is actually the start of a function, so start is sorry, divided by 4, and that's an integer division. And then the bytecode, we have the bytecode, or like the code, and the code is actually data. The code is data, perfect. Cool, and now at the end we can just like for f in funcs, we can just write how many functions we have. So let's do it like this, let's write the offset, no, the slot number, 2x, and then the length. And the length is going to be in hexadecimal, no. The length I'm going to do in this decimal, because why not? Okay. Now we can do this, I think. I always forget how to do it. Is it like this, slot? Code? I think it's like this. Unsupported, no. Was it like this? I seriously always forget how you do it. It has to be one of these. Okay, I don't remember how to do it. I'm sorry, I'm just going to not be lazy. Oh wait, no. Byte is required, slot code, length of this, perfect. Here we go. Okay, so we do not have a lot of functions. We have several functions, a couple of them rather long, a couple of them like these ones rather short, and then we have some medium length functions here as well. So what we can do now is we can start and analyzing the functions. I guess if the function is rather small, we can just let's make it like a disassembler, right? Disas and f. And yeah, I'm basically going to repeat what was said at the beginning. F code, okay. Perfect. What I'm going to do for now is I'm just going to print it. Yeah, I knew something was wrong there. So the F, what I'm going to do this. Okay, and I guess here. If SZ is smaller than, let's say 10, we will start with a small function, then let's discuss the function. Okay, yeah, perfect. Here we are going to do this. Okay, nice. Which means we need to start looking at the bytecodes. And to do that, I'm actually going to help myself. I did download the... Oh, thank you, Walter. Thank you for the donation. The donation reads tab space space long space tab tab space. Thank you. And space space tab to you. I'm going to look at the downloaded files for Arduino, or rather the opcode definition. There was something like opcode definitions, and the opcode definitions look like, I guess there are two types of them, but they look like this. You can download them on the manufacturer's website. I did show that before. And this is actually quite cool for us because like we can easily process this and yeah, just like write a disassembler based, or rather have this in a Python disassembler. So what I'm going to do is I'm going to copy this file to PY, like opcodes.py, that's how I'm going to call it. And now I'm going to do some creative remodeling. Let's do creative remodeling here. I have no idea what this is, like mob definitions. What's a mob definition? I don't know. An FFT definition. Okay, so let's start with they look actually identical, so I'm going to do the remodeling on all of them at the same time. Cool. Sync character, I don't think we need that. Wait, what just happened? Yeah, I think I accidentally removed. Not what I wanted to remove. Yeah, looks good. So, let's start. I do not need this. I do need this. This, then let me remove this, let me grab this, move here, do this, and add okay, so far so good. And here, instead of these, I'm going to remove these, and I'm going to change all of them to a hash. Okay, and this is Python syntax now. Perfect. And let's say this is like opcodes. Then these are the, what was it called, like mops, whatever. Okay, so spoiler alert, mops are actually like opcodes for matrix operations. And these are like FFT operations. There's a special extension instruction for these. Yeah, like you basically do a matrix operation, and after that you give opcode from the second table. Perfect, so we have this. Now we can actually do beta coding, which means from opcodes import everything. Nice. Now, in the disassembler itself, we take a look and we grab the, let's call it an op, and we need an opcode. Opcode is opcodes get op, or the default value is going to be this, and then we are going to print the op here. Yeah, I'm going to change it later. And put that. This is not going to work, obviously, but I need to start somewhere, and I'm going to start here. Okay. So, I guess now what we need to do is we need to start going through each of these instructions one by one. We have a select A instruction. A select A takes one more byte, and this is the registry number. As you remember, we have registry numbers from 0 to 127 because there are 128 registers. There are actually a couple of more, but that doesn't matter for this task. Now, what is select A? There is an A register, but the A register isn't really a register, it's an alias. It's a symlink, a symbolic link to a different register. And there are a lot of instructions which operate on the A register, which means that you can select any register you want and say that this is my A register, and then like for the next operation you just move it to a different register, and this is what the select A instruction does. So yeah, we need it to get a register number, so let's create a function which is like regnum, and or do we, yeah, let's just do num r, and this is going to return r and then the number of the register. Yeah. Perfect. So here what we actually do is op hex is going to be empty, and by default is going to be this, and this is no longer this, it's the op hex. Let's do it. I don't think these are going to be super long, but let's do 16 anyway. Op hex. Okay, and then we have op, like mnemonic or whatever. Mnemonic is nothing at the beginning, but no, it's opcode at the beginning. Cool. Now, and this is going to probably be a series of, how do we do it properly? Okay, because I do not want to write a lot of code, but I don't think this is avoidable a lot. Let's open the opcodes again. And here we have actually just these, but these take different types of parameters. And one of the parameters is the register number. So that's the regnum, let's say 0. And we want to say that after the select A, there is this regnum thingy. So what I'm going to do is I'm going to make a little change here. The change is going to be that I'm going to, make this, and this. Okay, so I created a tuple here. Everywhere there's a tuple. And here I can write regnum, and it will be understandable by the disassembler that after this opcode we are expecting So we need to return this, and the opcode is actually the first one. That's the mnemonic. And then for each argument in the opcode starting from 1, if any, obviously, we process it. So if the argument is actually a regnum, then we have to add to the mnemonic the... you know what? I'm going to increase here it by 1, not at the end. Yeah. We probably need an offset as well. It's I, and the offset goes here. Perfect. Okay, so if it's a regnum, we get, I guess we do not need this. We can just copy it, move it here. R and the number of the register, and what we fill it with is we fill it with I, because we increased I here. So yeah, so this is this argument, and then we can increase I by 1. Cool. Now let's try it again. And yeah, and we have here, not opcode, but mnem. Okay. So we select R127. Okay, that's a pretty high number of a register at the beginning. And then we use lsetI. And what is lsetI? lsetI means set register from immediate value. So we give it an immediate value. Okay, so lsetI takes an immediate value, and we need to reflect that in our disassembler. So lsetI takes an what kind of immediate value it is? It's a 1 byte, a single byte immediate value, a signed byte. So signed 8. There will probably be unsigned versions of it as well, and different sizes, I guess. So let's just do this. For unsigned. Okay, and yeah, now we need to handle another case, which is elif arg is actually one of these. Then we need to display various things, depending on which one is it. I guess I'm going to code them as they come. Here mnem plus, and let's do it like 0x and then 2x, like this, and it's supposed to be a signed value, but I'm not really unpacking it as a signed value. Doesn't matter. It's just going to be hexadecimal. Okay. So okay, now when we have an equal, and we already know that equal takes a function number, and this is the slot. So the slot can actually be also thought of as equal, like an immediate value, I guess, but an unsigned one, not that it matters in case of our code. Okay, and then we read. Okay, so we have already the first function, which is readable. We translated all the instructions, and I hope they are right. We select this register, we set it with the value 5C, and then we call O2. Do we have any function in the slot O2? It says, no, I do not believe this is correct. Let's see if the slots are actually counted correct. No, because I take I should have taken start here. That's why it doesn't make any sense. Perfect. So yeah, it sets this value and then it calls this function. So I guess I'm going to remove the size limit. No, I'm still not going to remove the size limit. I'm going to look at this function instead. This function has save int. Okay, save indirect, it takes a register number, so it's a regnum, and it looks like it's a poke, basically, a pointer to reference. Takes a register number. Then we have linc, L, and it also takes a register number. So link takes a register number. And link increments a register. We give it a register and it does a long increment on it. Okay, so it basically saves this register and then it increments it. No, it doesn't save a register. It saves something under this register. What does it save under that register? It saves the, register A under here, and then it increments. You know what? It looks like a push. That looks like a push. So yeah, the 90 is probably a push. And then here we have LDEC, and LDEC probably like linc takes the number, the register number. So let's just change it. Then we have load int, which is the exact opposite. So this is probably going to be a pop. Yeah, to register 0, this is a surprise. Not register A. I would expect A here. It takes, it loads. So this is probably going to be a pop. Let me see, where's my. We do this. There's load int and the regnum. Cool, then there's the else set 0, which probably doesn't take any parameters because there's a ret after it. What does else set 0 do? Else set 0, it does this. Register A gets the value from register 0. So register 0 seems also to be a special register. So yeah, again, this is like push, this is pop. This is how it looks. And I guess we are out of short functions. Let's go with these functions. They are only 24, so they might be easy to understand. I'm going to increase the limit here to 25. Okay, we have select. This is already correctly parsed, correctly L shift. We do not have L shift. L shift takes the register number. Like, I don't know, like half of this just take the register number. L shift. And yeah, L shift is, a typical shift left, which is this operation. And it takes a register number and it operates on register A. Perfect. Then we have L write a something. Oh, this takes more. It takes this is big endian, some big endian value. L write. So L write is something new. Write A, because we have this immediate, but it's signed, unsigned. Long integer value, it doesn't say, so I'm going to go with unsigned. Which means we do have to implement it now. It's 32-bit, then we need to make the value. Okay, let's just do it. Not be lazy, let's just do it. This is the most significant bit, which means it needs to be pushed. Okay, this is +1. Yeah, I'm just putting the value together using bit shifts. So pre-standard here doesn't have to be pushed at all, actually. Perfect, and we can do value. It's 8 bits actually, and we have to push by 4. Cool. Okay, and it says dv is not, where's dv? Here, v. Cool, so it writes this value, which is pretty weird there, and then it does a lore, which is or calories. No, that's not calories. It takes a register number. Surprise, surprise. So lore takes takes a register number. I'm assuming that ELXOR also takes a register number and so on. So here not A, it doesn't take anything. These don't take anything. These take also a register number, so let me do that. Okay, then eSave A. eSave A, is it like EEPROM writing? What's eSave A? eSave A. Save register A to EEPROM. Yeah, that's EEPROM writing. That's flashing an EEPROM. Like E-write, but the value is taken from the register. That's interesting. And E is actually the slot in the EEPROM. So it's again an address of a 4-byte word, which means it's going to be an EU8 for all intents and purposes. Okay, then it selects. Okay, so what is going on here? We are not putting enough data here, by the way. How do we do that? How do we put enough data in an automatic fashion? I know. We have this. Now, what we need to do, we have offset. So op, no, this is the wrong way to do it. This is okay, but this is the wrong way to do it. What we need is at the end, when we know the new location of I, is we need to grab the data which is there, so the data which is between offset and I, and do a hex to it. This is the proper way. Yeah, now it's better. Now it shows the whole instruction. Okay, I have no idea what this is, but it puts. Wait, this is bytecode, because if it pushes something to it writes something to the last slot of FF, and it does R16 an OR of this value with R16. So whatever is in R16, it's being pushed by LOR. How much are you? Oh, shift R2. Okay, so it's shifting by 16 bytes. Whatever is the content of this register is being shifted by 16. Left shifted, R16, and it's being ORed here. So it's going to be inserted in this place. So what is this code doing? Like 80 is a return value, like a return. So this begins and ends with a return? That doesn't make any sense. But we have this db here. What is db? Maybe I'm reading the value incorrectly. I might be reading the value incorrectly for some reason. The 32-bit. It's +1, +2, +3, plus... Yeah, this is a mistake. This is why it shows 80. It's not 80, it's 03. 03DD. What is 03DD? Let's look at... Sorry, let's look here. On the opcodes. So 03 is clear, and DD clear, but I don't get that clear. DD is eload A. So it loads from a given register the value to A. I'm guessing it's taking the register number. No, eload A, it's taking the register slot, register address. Which means this is in U8. Okay. Did I do the +1? What is this 03 again? Because it doesn't make any sense. We put 0 in the register, in a given register. No, this is the length of a function, right? So this is the length of a function, and then this is the bytecode. And the bytecode is loading something from an address which we... okay, this means that basically there is no opcode which takes the address in form of a register. And this function, what it does is basically creates a new function, like dynamically create a function in a memory which reads, or I'm guessing here db, I'm guessing is going to be a write to the given address of memory. So this is basically a workaround. This is not part of a challenge probably. XDB. Yeah, eSave. Yeah, so this is just writing to memory. So I guess we know that A is write something which is in register A to the specified memory address which is in register R2. Yeah, so it wasn't R16, it was R2. And here is like, there is an address in register R2, in an EEPROM address, and this is going to load the value from that EEPROM address and put it somewhere. Cool. Yeah, and yeah, this is like writing the function in memory and it's calling it. So it's a self-modifying code basically. Well, it doesn't modify itself, it just creates dynamically a new function in memory. So we have this, I guess, figured out. If we see a call to one of these, we will know what's going on. So I guess what we can do now is we can remove the limit whatsoever. I also see that we are running out of time today, so I guess this topic is going to be postponed to next week, or when I will finish going through, like writing the disassembler and going through this challenge. But the last thing I want to do is I want to remove this limit for today. Okay, there's quite a lot of code. There are some V's. No surprise. Okay, like copy 0. Yeah, we'll have to. Oh, there's mob. I wonder if this is like just an artifact or if we are going to do matrix operations. And there are a lot of these here. I'm a little worried. But on the other hand, looking at their functions which are trying to dynamically write and read from EEPROM, we should expect self-modifying code here. So okay, let's finish for today. I'm going to still answer the questions which you had. And next week I'm going to finish writing the disassembler for it, and we are going to analyze the code, and we are going to hopefully find the flag. So I guess that's it for this, and let me look at the questions. And if you have any questions, remember to ping Fox or Charlie. He will add the questions to our list. So Hexadecimal says, quick question. I'm studying software development, currently started second year, third year, 3-year program, pure coding, no theory, all application. I'm also 25. Is it too late for me to get into security? Am I too old? You are not too old. Do not worry about age and just go for it. Basically, yeah. Like, age is not a restriction in this case. The amount of time you can put into actually learning security is another thing. Security is, if you have programming background, that's great. For security, it's amazing. It will really help you in security if you have that. But in security, there's still a lot of learning, especially if you want to be on a decent level. Emil says, so I am a first year IT student thinking about what to learn in my free time. Uni courses are boring. Some crucial specific topics which would help me in the future. Depends on what do you want to specialize in IT, because IT is broad, right? So you might be on a university doing IT courses, meaning you want to do networking in the future, you might want to do like databases in the future, or you might do programming, or you might do web development. So that doesn't tell me too much. Feel free to catch me after the stream and we can chat about it. Now, one note, depending on your university, if a course is boring for you, what you can do is you can go to the professor and tell them, don't tell them it's boring, tell them that if there is a possibility to pass this course by bringing in a project which is related to it. And I've actually passed most of my IT courses like that. But I like set up really ambitious goals, and then either alone or with friends, we created some really cool projects. Pavel, thanks for today. Thank you for being here, Pavel, and thank you for the donation. Yeah, so going to the previous topic, basically when you do the project, you will have to do probably a lot of coding, a lot of thinking how to do it, and that in the end make sure the project is ambitious. You will not probably have to go to the lectures or to like the labs and so on. Instead, you will have to just focus on writing your project. If it's ambitious enough, you will learn a lot on how to work on slightly larger projects, how to work with others on a project and so on, how to design it. That's usually a benefit, but make sure to include in that project a lot of things which you would otherwise learn during the course. That's not always possible. On my university, it was possible for a lot of courses. So yeah, there you have it. And f-strings. I have no idea what f-strings are. What are f-strings? Dohan, you have to tell me what are f-strings. Python improved formatting strings. Oh, you mean with oh, that's, I don't know the name. F-strings. Yeah, no. Yeah, how about no? I don't know. It looks like the formatting with the new f-strings looks like formatting with C++ cout, and this is not what I want to do. I'm pretty well versed now with formatting in an old style, and the old style is pretty good as well, so I don't see the need to switch. Cool, so I guess that's it for today. It's been over 2 hours and feels like 30 minutes. Well, not for my vocal cords. It was my opinion on OSCP. You mean the certificate? What's it called? Like Offensive Security Certified Professional? I do not have an opinion on it. I do not personally do any certifications for me because I do not see the need. Yeah, I mean, I prefer CTFs for certifications, but that's my personal feeling. I know that companies do. There are companies which require certifications. There are companies which don't care about it. But there are some companies which require certifications, like be it certified ethical hacker or this one like offensive security certified professional or some other ones. If you want to get it, do it. It will not hurt you to have a certificate. It's not required in a lot of companies either. So it's up to you, basically. That's my thought about it. I do not have any thoughts about the merits of the certificate because I just didn't look at it. That's it. Perfect. So thank you for today. Thank you to Foxtrot Charlie, who was my main moderator today. Also thank you to Disconnected, who I saw on the channel. Remember that paged out deadline is in 3 weeks, and see you tomorrow on the Polish stream if you speak Polish, and in a week on the finishing of these tasks on my English stream. And that's it. One more question. What is your advice for beginner malware analyst? Reverse malware. Yeah. And learn about how to do it properly, and learn about, all the modus operandi, if you will, like basically how to do it without shooting yourself in the foot and infecting your local network or infecting your computer. One thing you learn really fast, and this is something I've learned also the hard way, is you probably want your download directory to be set to have the attributes but do not allow execution of files which are in that directory. Because otherwise you download a file and you misclick and you suddenly run the malware. Yeah, I'm sorry, like, now you have to do really fast analysis to figure out what happened and if it's actually encrypting your hard drive or not. So yeah, that's a tip. I'm not sure you can do it on Linux. You can do it on Windows. You can set an attribute for a directory that no files in it can be executed, no executables in it will be executed. So but that, apart from that, we'll learn like that you need virtual machines, that you probably shouldn't have network, and so on and so forth. And then learn reverse engineering, and learn probably also Yara, how to make Yara signatures if you care about that. But just focus on learning reverse engineering and do it practically, obviously. Cool. So that's it. Thank you. See you folks next week, and have a great evening, day, or whatever time zone you are in. Bye bye.